Good afternoon, dear students. Yes. So today we are going to start with a new topic. So the new topic is coordination compounds. Okay. So you might have gone through the synopsis, right? So please go through the synopsis. So based on the coordination compounds, okay, we are going to solve some MCQs today and as well as tomorrow. Okay, so this particular chapter will be there for 2 days because the weightage for this chapter is more. Okay, so because of that, we are going to deal with this chapter for 2 days, so today and tomorrow. So please go through the synopsis. So I hope you have gone through and during your academic year also. Okay, so in 12th, okay, so in your 12th itself, this chapter have you have studied. So you know the basic things, okay, basic concept which are involved here about the ligands, right? Then the theory. So these are CFT, right? VSCPR. So these all theory you are studying here. Then about the ligands, type of ligands, right? How the complexes are formed, type of complexes. So, okay. So these all things. So related to this, I have taken few questions. Okay. So I tried to like cover all the important concepts. So let us start. So this is the first question. So we'll start with the basics first. Okay. So the first question is an example of double salt is. Okay. Can anyone tell me what do you mean by a double salt? Yes. What do you mean by a double salt? What do you mean by double salt? Can anyone tell me? You can use a chat box, okay, for answering. So there you can leave your answers. Yes. Others? You can use the chat box, okay, for answering your answers. Okay, I have a few answers, so let me go through. Okay. So double salts are what? Double salts means what? Okay. So double salts are the addition compounds, okay, which dissociates into the simple ions when you add it in water. Okay, so when the salt, when you add it in water, okay, if you add this double salt into the water, so this is formed by the combination, means by addition of two salts. Okay, and when you add it in water, it will dissolve. Okay, it will dissociate completely into simple ions. Fine. So what are the examples? The example is A, bleaching powder, B, K4, FeCN6, C, hypo, and D, potash alum. So, okay, I've got answers. Vedvati has answered it as D, Pavitra has answered it as B, Sharath has answered it as B. Okay, so what is the correct answer? Yes, so double salt. The answer is D, potash alum. Okay, your potash alum is an example of a double salt. Okay, so let me write the formula. Okay, so potash alum. So potash alum, it is K2SO4 dot Al2 SO4 thrice dot 24H2O. Okay, so it is an example of double salt. Fine. So some more examples. Some more examples you can keep in mind. It will be helpful. Carnallite. Okay, carnallite. Then Morse salt. Okay, Morse salt. So Morse salt is also example of your double salt and potash alum. Okay, so carnallite, it is made up of KCl, MgCl2, and 6H2O. Okay, and Morse salt, it is made up of what? FeSO4 dot ammonium NH4 twice ammonium sulfate dot 6H2O. Okay, so these are the examples of double salt. So please keep this in mind. So double salt, it is made up of what? It is formed by addition compound. So when you add it in water, it will dissociate into simple ions. Okay, let us go for the next question. So the complexes. So these are the complexes. Okay, one is a complex of hexamino cobalt, another is hexacyano chromium complex. Okay, and so the hexaaminochromium and hexacyanocobalt are the examples of which type of isomerism? A. Linkage isomerism, B. Ionization isomerism, C. Coordination isomerism, and D. Geometrical isomerism. Yes, what is the example? What is the example? Yes. So you might have gone through the isomerism concept, okay? Of what is linkage, what is ionization, what is coordination, and what is geometrical. So apply the definition and you can use it here. Yes. So, okay. So Vedvati has answered it as C. Vedvati has answered it as C. Others, what are your answers? So the complexes, okay. So here what you can see, one is a complex where your amino group is associated with cobalt. Another is a complex where chromium is associated with the ligand of cyano. And here you can see, okay, the central metal atom is changed. So it is cobalt, CN6, and chromium, NH3, 6. Okay. So here, what type of isomerism it is exhibiting? So it is a coordination isomerism. Okay, it is an example of coordination isomerism. Option number C. Okay, Vedvati, Pavitra, yes, your answers are right. Very good. So here, it is example of what? Coordination isomerism. So what do you mean by coordination isomerism? So coordination isomerism, it occurs when you have a cationic and ionic complexes of different ions. Okay, when cationic and ionic complexes of different metal ions are present in a salt, then this is what it is called as the coordination isomerism. Okay, coordination isomerism where you have cationic and anionic complexes of different metal ions. You can see the central metal, okay, it is associated with two different ligands here, right? So it gives you, so this particular complex, okay, it is an isomer of this. Okay, you can see that the coordination central metal is the same, only the ions are different. So it is coordinating. Okay, the cationic and ionic complexes of different metal ions, they are present in the salt. So option number C is the correct answer. So let us go for the next question. Fifth question. Which of the following pairs represent linkage isomers? Yes, which of the following linkage? Linkage means what? Yes, can anyone tell me what is the meaning of linkage isomerism? What do you mean by linkage isomerism? Yes? Okay, I've got one answer. Pavitra has answered it as B and Vedvati have answered it as A. Okay. Okay, let us see. So linkage isomerism means what? Complexes are having same molecular formula. Okay, complexes having same molecular formula, but it differs. Where it differs in the mode of attachment of linkage. Mode of okay. So the mode of attachment of ligands to the central metal atom or ion. Okay, so the mode of attachment of the ligand to the central metal ion or atom or the ion is different. Okay, so because of that, it is called as the linkage isomerism. Now here, which are the different this. So one is example is nitro. So nitro can link from NO, okay, or it can link from O. So it can link from NO to, or it can be linked to this. Then one more example is your thiocyanate. Okay, it can link from SCN, or it can link from NC S, like that. Okay, it can bond through S, or it can bond through nitrogen. So these are the example of the ligands. Okay, where you at only one side it can get linked. Okay, so mode of attachment is different, but it will link through only one atom. Now, what is the example? Fifth one. So which of the following pairs represent? So what answers you had given? Pavitra B and Vedvati A. Okay. So A is the correct answer. Okay. You can see the mode of attachment is different. So it is A. A is the correct answer. Okay. Now here you have NH3, here you have Cl. These are the regular ligands. Okay. But here you can see in this NCS and another is SCN. Okay. So the mode of attachment is different. The molecular formula is same. Okay. When you see this and this, the molecular formula is same. Okay. So option number A is the correct one. Okay. Let us go for the next one. Next question is this. Which of the following organometallic compound is pi and sigma bonded? Which of the following organometallic compound is pi and sigma bonded? Yes. What is the answer? What is the answer? What is the answer? What is the example of organometallic compound which is pi and sigma bonded? So the answer is D. Okay. Cobalt, CO5, NH3, 2 plus. Okay. So in this complex, the cobalt atom is attached to NH3. Okay. It is attached to NH3 through the sigma bond. Okay. And that with the carbonyl. Okay. With this carbonyl by a pi bond. So, okay, so it is a organometallic compound. So option number D. So how is the attachment? So organometallic compound. So carbon, your cobalt is bound to the NH3 with sigma bond, and that with the carbonyl groups with the your pi bond. Okay. Coordination compounds have great importance in biological systems. In this context, which of the following statement is incorrect? A. Cyanobalamin is B12 and contains cobalt. B. Hemoglobin is the red pigment of blood and contains iron. C. Chlorophylls are green pigment in plants and contains calcium. D. Carboxypeptidase A is an enzyme and contains zinc. Yes, which is the incorrect statement among the following? Yes, which is incorrect. So coordination compounds. So the metal, okay, it is bonded in the central and it forms a coordination compound. And this coordination compound, it has a very important role in the biological system. Okay, when we are talking about cyanobalamin, okay, so it is B12 and contains cobalt. Yes, so cyanobalamin, it contains cobalt. So this is a correct statement. Hemoglobin, your HB. Okay, it is made up of iron, so Fe. So this is also a correct statement. Then carboxypeptidase, okay, is an enzyme and contains zinc. So this is also a correct statement. Chlorophyll, okay, chlorophyll, it is a green pigment and it is formed in the plants and it does not consist of calcium, but it consists of what? It consists of porphyrin. Okay, it consists of what? Porphyrin. Okay, it consists of porphyrin ring and the metal Mg. It is linked to metal Mg and not calcium Okay. Okay, so it is C. So C is the incorrect statement. Okay, C is the incorrect statement. Okay. The complex ion which has no d electrons in the central metal atom is the complex ion which has no d electrons in the central metal ion is. Yes, go through the options and tell me the answer. Okay, Pavitra has answered it as C. So let us see. Which kind of isomerism is exhibited by octahedral CO, that is tetraamino bromo cobalt. Okay, which is the kind of isomerism exhibited by this octahedral complex. Yes. A, geometrical and ionization. B, geometrical and optical. C, optical and ionization. And D, geometrical only. Yes. Which kind of isomerism is exhibited by this complex? Yes, you can give the answers in the chat box. That is CONH3 Br2Cl. Okay, Vedvati has answered it as C. So it will show both geometrical as well as ionization. Okay, now that is CO. The cobalt can exhibit as CONH34 Br2Cl and CONH3 4 BrCl. Okay, Br. So these are the ionization. These are what? These are the ionization isomers and geometrical isomers. So cobalt, so it can link to NH3, NH3, then NH3. Okay, NH3 octahedral means it is attached to 6 ligands. Okay, then cobalt, Br, NH3, 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 Br. Okay. Then your cobalt, Br, then Cl. So this is cis and this is trans geometrical. Okay. And we'll write for this next complex. When cobalt is attached to this, so it will be NH3, NH3, NH3. Okay. And your cobalt, NH3, 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 Br, Cl, and here one NH3. So this is a trans, this is cis. So of the two complexes, okay, of this two complexes. Okay, so this is a octahedral complexes. Okay. So this particular complex, octahedral complex, it will be okay, it will be exhibited both geometrical as well as ionization isomers. Geometrical means it will show both cis and trans forms. Okay. And ionization means what? It can get ionized in different ions. Okay. Let us go for the next one. Cyno group. Cyno is a strong field ligand. This is due to the fact that why cyno is a strong field ligand? It carries negative charge. It is a pseudo halide. It can accept electrons from metal species and it forms high spin complexes with metal species. Yes. So it is a cyno group. It is a strong field ligand. Okay. Because it is a pseudo halide. Because these ions are strong coordinating ligands and uh, okay, and they have a tendency to form quad bond. They have a tendency to form sigma bond. Okay, and pi bond as well as they can form pi bond. So this is the reason. So from the metal to pseudo halide. So sigma bond means what? From the halide to the metal. So from the halide to the metal, the bond is formed pseudo halide to the metal, and pi bond means the metal. The bond is from metal to the pseudo halide. Okay, pseudo halide. So it acts as what? It acts as a what? It acts as a strong field ligand because it is a pseudo halide. Okay, let us go for the next one. The number of geometrical isomers for this particular complex of platinum is How many possible geometrical isomers are there? Geometrical isomers of platinum NH3 twice Cl2 complex. So platinum in the center, Cl, Cl, NH3, NH3. Okay. And again one is platinum NH3, NH3, Cl, and Cl. So what is this? This is a cis and this is a transfer, right? So it will show how many complexes? A. Yes, Vedvati has answered it right. It will form two isomers, geometrical isomers. A is the answer. Very good. Let us go for the next one. Which of the following will exhibit maximum ionic conductivity? Yes, maximum means when the complex is added into water, okay, it will give maximum ions. It will give maximum ions. Okay. So how much? So when you add this, suppose if you add K4 FeCN6, okay, in the water, it will form what? It will form FeCN6 minus 4 plus 4K plus. How many ions? So this is 1 plus 1, 5. So it is 5 ions. It will dissociate into 5 ions. Then if you have CO, NH3, 6, Cl3, okay, if it dissociates in water, what it forms? So CO, okay, NH3, 6, 3 plus and 3 Cl minus. So this is 1 plus 4. This is 4 ions. Okay. So this is for B. This is first, second. Then third one is copper, CN3, 4, Cl2. When it dissociates in water, how it will be? It will be Cu, NH3, 4, 2 plus. Okay. Plus 2 Cl minus. So it is 1 plus 2, 3 ions. It will dissociate into 3 ions. Last one, nickel tetracarbonyl complex. Nickel tetracarbonyl, when it dissociates in water, it will give no ions. Okay, no ions is formed. So no ions. So the how much maximum it is seen in the option number A. Okay, in the complex A, you can see that the maximum ions are produced. Okay, I hope this is clear. Yes, shall we move for the next one? Is it clear up to here? Yes. So these, so mostly the questions here are asked on the your isomerism. Okay. Questions are most probably asked on isomerism. So isomerism, they okay, very important. So of the following complex ions, which is diamagnetic in nature? So these are the four complexes. Okay, you have to see which is the complex which is diamagnetic in nature. Diamagnetic means all the electrons are paired. Okay, they are paired. Yes. See what the answer you'll get. Okay, Vedvati has answered it as B. Okay, B is the correct answer. So nickel, okay, cyano is a very strong ligand. So X plus 4 into minus 1 equals to minus 2. X minus 4 equals to minus 2. X is equals to plus 2. Okay, so nickel is 28. So it is 3D8 for S2. So when nickel is in plus 2 state, it forms argon 3D8 system. Okay, now nickel, okay, it is a tetra, okay, it is a tetrahedral complex because the complex number is 4. Okay, and you can see that first, if you write the electronic, so filling of electrons 1, 2, 3, 4, 5, 6, 7, 8. So you can see there are two unpaired electrons. Okay, but from the experiment, if you conduct the experiment of this complex, we can see that this complex is diamagnetic in nature. So there is a possible, okay, that is this 3D electrons, okay, they will rearrange against the Hund's rule, and because in the presence of this what, so when it comes in presence of the your cyano group, okay, what will happen? the ligands, they will get rearranged and they will get paired. They will get paired. Okay, 8 electrons they will paired among themselves, because the when it comes in the presence of strong ligand like the cyano group. Okay, so and it will show what type of hybridization. It will show dsp2 hybridization. Okay, so one D, one S, and two p orbitals are involved, and thus so the it is diamagnetic in nature. So option number B is the correct answer. Okay, let us go for the next one. Correct name of this complexes. So how you will name this complex? Yes, how will you name this complex? So first find the oxidation state of iron in that complex. So K4 FeCN6. Okay, so this is what X plus minus 1 into 6 equals to minus X. So it is plus 2. So the Fe charges plus 2. So the name, okay, so the first is the outside metal. So we'll write potassium. So first you have to name that potassium. Then is how many names? It is hexa, cyano, and ferret. The charge is 2. So hexa, cyano, ferret, 2. So option number C. Option number C. Okay, I've got the answers. Okay, Shrikant and Vedvati. Yes, your answers are right. It is option number C. Okay. So naming the complex is also very important. Okay, this can be asked like this. So complex will be given and you will get 4 different answers. Okay. Ammonia forms the complex ion. Okay, this is a complex ion which is formed by the ammonia with copper ions in alkaline solutions, but not in the acidic solution. What is the reason for it? Ammonia, it forms a complex of copper, okay, in alkaline solutions, but not in acidic solution. What is the reason for that? What is the reason? What is the reason for that? Just go through options. A, in acidic solution, protons coordinate with ammonia molecules forming NH4 ions, and ammonia molecules are not available. In alkaline solutions, insoluble copper hydroxide is precipitated, which is soluble in excess of any alkali. C, copper hydroxide is an amphoteric substance. D, in acidic solutions, hydration protects copper ions. Okay, Vedvati has answered it as A. So yes, others, what is the answer? In acidic solution. Okay, so if ammonia is our ligand, so when you take this in acidic solution, what will happen? It forms ammonium plus ions. Yes, it becomes ammonium. So it is very difficult, okay, to be in the complex state, because ammonia, we need ammonia molecule, because there should be free lone pairs of electrons. So this will get attached to the central metal atom. So option number A is the correct answer. Okay, option number A is the correct answer, because in acidic medium, if you take this ammonia, it will react with the H plus ions and it forms ammonium. Then it won't form any your complex. Okay, complex form this. Okay. EDTA is what is EDTA? A monodentate ligand, bidentate ligand, quadridentate ligand, or hexadentate ligand. What is EDTA? EDTA is EDTA is what? Yes, EDTA is a mm, EDTA. Yes, others answer. answer? What about others? What is the structure of EDTA? So EDTA is CH2, N, N, okay, then CO minus, CO minus, CO minus, CO minus. So it can link to this nitrogen. So 1, 2, 3, 4, 5, 6. It is a hexadentate ligand. So the linkage can take place from this nitrogen, from this oxygen, here oxygen, here oxygen, and here oxygen. So it can link through 6. Okay, so it has 6 donor atoms. Okay, so it can donate 6 pairs of electrons to the central metal atom. So it is a hexadentate ligand. Okay, please remember the structure of EDTA. Okay, ethylene diamond tetraacetate. Okay, so this is a structure of EDTA. The IUPAC name of, so IUPAC name of this particular complex is, what is the IUPAC name of this particular complex? K2, K2, PtCl6. It is what? First we write the metal element out of the complex potassium, then hexachloroplatinate. Okay, platinate. What is the oxidation state? So the oxidation state of platinum here is, okay, so platinum X plus 6 into -1 is equals to -2, then it is X minus 6 is equals to -2, X is equals to -2 plus 6 equals to 4. So it is plus 4, 4. Okay, so it is plus 4. Yes. Shrikant has answered it as B. Yes, Vedvati has also answered it as B. B is the correct answer. Potassium hexachloroplatinate 4. Potassium hexachloroplatinate 4. Okay, option number B. Okay, let us go for the next one. Which of the following is an organometallic compound? Which is a organometallic compound? So organometallic compound means what? Yes, compounds in which the metal ion is directly attached to a carbon atom. Organometallic. Okay, organo means what? Organo means the compounds which are made up of carbon. So organometallic means what? So the metal is directly linked to the carbon atom. Okay. So here, which is the example? What is the example of organ? Yes. Which of the following is an organometallic compound? Lithium methoxide. Lithium methoxide means what? Methoxide is OCH3. Okay. So no. So lithium is attached to oxygen. So this is wrong. Then lithium acetate. Acetate is what? CH3COO lithium. So here also lithium is attached to oxygen. Wrong. Then lithium dimethylamide. Lithium dimethyl. So dimethyl and amide. C double bond O NH2. Okay, so lithium dimethylamide. So here it is linked to lithium. Okay, so lithium dimethylamide. So here also it is wrong. Methyl lithium. Okay, so it is Li linked to carbon. So it is D. Option number D. Okay, option number D is the correct answer. Okay, let us go for the next one. The IUPAC name of this is, what is the IUPAC name of this particular complex? What is the IUPAC name of this particular complex? Yes. So when you write, okay, we have what? So there are two complexes. So it is tetraamine, sorry, tetraamine, okay, nickel. What is the nickel 2? And this is tetraamine nickelate tetraamine nickel, okay, and tetrachloro nickelate, okay, nickelate 2. So it is option number C. Are you getting the same? Yes, Shrikant has answered it as C. So tetra amino nickel 2 and tetrachloronickelate 2. Okay. Which of the following statement is incorrect? Which of the following statement is incorrect? Which of the following statement is incorrect? So let us see about nickel. Okay, it is which of the following statement is correct? Okay, about the nickel. So nickel is, first we'll write the atomic number. Okay, electronic configuration argon 3d8 and 4s2. Okay, now nickel in the first complex, that is nickel, we'll see Cl4 2 minus. Okay, so when you write the electronic configuration, okay, when you find here, so nickel is in +2 state. Nickel is in +2 state. So if you write the distribution of electrons, so it will be 1, 2, 3, 4, 5, 6, 7, 8. So chlorine is a weak field ligand. Okay, chlorine is a weak field ligand. Okay, then you can see the number of uh, chlorine is a weak field ligand. So this is your 3d electrons. Next is your 4s electrons, and then is your 4p electrons. Okay, so the number of unpaired electrons are how many here? 2. So this is paramagnetic in nature. Next is nickel Cn4, nickel Cn4 2 minus. So here cyano is a strong field ligand. Cyano is a strong field ligand. So what will happen? The rearrangement will takes place and the electrons will get paired up. The electrons will get paired up. Okay. The electrons will get paired up. So here there are 0. So this is diamagnetic in nature. Then one more complex is nickel tetracarbonyl. Nickel tetracarbonyl. So here nickel, okay. How many electrons in nickel? It is D8 system only. Okay, so it is nickel 0. So it is 1, 2, 3, 4. So it is 1, 2, 3, 4, 5, 6, 7, 8. Okay, and here S2 electrons are also involved. So the number of unpaired electrons are 2. It is paramagnetic. So which is the correct answer? It is nickel tetracarbonyl and nickel tetracyano. So this is a correct answer. Okay. So nickel tetracarbonyl and nickel tetracarbonyl and nickel tetracyano. Okay. So these are diamagnetic in nature and nickel tetra, that is tetrachloronickelate, it is paramagnetic in nature. Okay. Now here this will undergo rearrangement. This will undergo rearrangement. What will happen? These electrons from sp, okay, s will get rearranged here. So 1, 2, 3, 4, 5, 6, 7, 8. So these are the 8 electrons from here, and these 2 electrons will get paired up here with these 2. So it will form your what? sp3 hybridization. In sp3, so it will form diamagnetic. So option number B. Option number B is the correct answer. Okay. Among the following complexes, optical activity is possible in. Among the following complexes, optical activity is possible in which of the complexes? So it is possible in the second complex. Okay. So if you have cobalt, okay, if you have cobalt and if you have your Cl here, if you have your water molecules, and when you have your NH3. So like this, one possibility, and another possibility is cobalt, Cl, Cl, NH3, NH3, H2O, and H2O. So this is the another possibility. So it is optical activity. It is possible in the D complex, second complex. Okay. Last, IUPAC name of this complexes. So when you have more than one this what ligands, so that time you have to follow alphabetical order. Okay. So you have amine, bromo, nitro, and fluoro. So first, what will come here? Yes, IUPAC name. First will be your amine because A. So it will be triamine. Okay. Then will be your A. Then comes your bromo group. Then will be your chloro group. Then will be your nitro group. And then will be platinum. Platinum 4. And outside the bracket, it is fluoride. So which is the correct answer? It is C. Triamine, bromo, fluoro, nitro, platinum 4, fluoride. Is it clear? Yes? Okay. So these were the questions. Okay. So the remaining questions we will deal in the next class. So we are going to continue with the coordination compounds in the next class also. Okay. Any doubts up to here? Yes. Any doubts up to here? Yes. Any doubts up to here? So we have covered today some 2022 questions. Okay. So again, few more 20 questions we'll be solving in the next class. Okay. So uh, so I have tried to cover, okay, some important concepts. So the remaining things, okay, some more questions, so that we'll be dealing in the next class. Fine. So I hope you have understood today's session. So tomorrow we'll continue with the same. So thank you. I'll end the session here. Bye.